Hey Math 1, Mr. Zamuda here, and we're going to be going through the Unit 3 study guide, the Unit 3 review. And for this video, we're just going to go through the first page. So just question number 1 here. In the table here, we have the miles an Olympian bike rider has traveled as he's training for his next event. The distance is the total number of miles he has gone over the past 9 days. So on the first day, he traveled 13 miles, and on the second day, he traveled a little more, so now he's at 22 total, and so on. You can see on the 9th day, he had traveled a total of 81 miles. And again, this is on bike. So what we want to do for this is we want to determine a linear regression for the data. So remember, what a linear regression is we want to find an equation, y equals mx plus b, that models this data. And to do that, I'm going to pull up Desmos. And to do this, and I really suggest that you practice on your own here, you hit the plus sign, hit the table, and then here we want to type in all the data. So in my x column, I'll do time, and for the y column, I'll do distance. So I see that the x column was really just 1 day, 2 days, 3 days, 4, and it went all the way to 9 days. Oops, one too many. And in the y column, I'm going to type in the other stuff. So 13, 22, 35, 37. $48, $63, $72, $79, $81. Okay. All right. So once you have your data entered there, if you zoom out, you can actually see the points, and we can see each of these points. Now what we want to do is we want the calculator to come up with an equation, y equals mx plus b, that looks similar. That looks similar to y equals mx plus b, just a little different. Instead of just y equals mx plus b, it's going to be y1 squiggly mx1 plus b. So to do this, go to your letters, hit y. Remember, we want y1, so then you have to type in the number 1. So y1, and instead of equals, you want a squiggly. That's down here. So y1 squiggly m, and then we want x1 plus b. Don't forget the plus b. So plus, and then the letter b. If I were you, I would definitely write this down somewhere, maybe even on your study guide. That way you remember what it is that you have to type in the calculator. And if you see here, it gives you the line. It graphs the line of best fit for you. And it gives you what the equation is down here. We can see that the slope is 9.05, and the b value, the y-intercept, is 4.75. So, going back here, I'm going to write my equation. Y equals m is the slope, and we found the slope to be 9.05. X plus b, and we found b to be 4.75. So that's what the calculator gave us. One thing to notice, it did say to round the y-intercept to the nearest tenth, so 1 decimal place. So if I wanted to round both of these to 1 decimal place, be y equals 9 points, and then the 5 makes the 0 go up to a 1. So 9.1x plus, and similarly over here, the 5 makes the 7 go up to an 8. So here we have y equals 9.1x plus 4.8. And then it did say to define our variables. To me, we define them up here, right? So we know x is time, we know y is distance. Make sure that you do define what it is that you're defining as x and y somewhere in the problem. Okay, so now that we have this, guys, the rest of the problem is pretty much easier. So identify the slope and the y-intercept and explain what they mean in the context of the problem. Well, the slope is the number that's with your x. That's your m. So in this case, it's 9.1. And the slope is always written as a fraction. So it's actually 9.1 over 1. Slope is always a fraction. And then the y-intercept is 4.8. But the y-intercept is also always a point. And it's always a point, 0, comma, and then whatever the y-intercept is. Now, when it comes to explaining these, this is where you have to be a little understanding of what it is that we're talking about. So for slope, recognize that slope is always a change in y over a change in x. So it's y over x. So what this means is for every one, what does x represent? X represents days. So for every 1 day, (9.1) is the distance, right? So 9.1 is y, the distance. The biker increases his distance by 9.1 miles. So for slope, you want to either mention increasing or decreasing. And we know that it's increasing because it's a positive 9.1. So for every 1 day, the biker's increasing his distance by 9.1 miles. And then what does this mean? 4.8. 0, 4.8. This y-intercept doesn't always make sense in linear regression, and that's okay. But what this means, guys, is in the equation at 0, remember 0 is x and 4.8 is y, at 0 days, or at day 0, the biker travels 4.8 miles. That's a little tricky there, but that's what you want to talk about. The y-intercept is at day 0, and the slope we're talking about for every 1 day. Are we increasing or decreasing? All right, moving on. Now that we have this, we want to sketch the scatter plot. And this is honestly what we see here. So it should look something similar to that. So here, I'm going to graph the points first. So 1, 13, somewhere down here, 222, 335, 548, 663, and then we have something that looks like that. So notice it says sketch the scatter plot, which we just did, and draw your linear regression line. Be sure to label your axes. So for right now, for this unit, guys, I want you to draw your line as best as you can where you think it fits the data. So do your best to just draw the line where like we can see that it's like kind of in the middle of all the data. So maybe something like that. Okay. I'm not looking for perfection here, but it should be something that fits. So don't give me a line that looks like that, because that clearly does not fit the data here. So again, just kind of roughly draw it. Right, so we did the scatter plot, we drew the line, and we want to label our axes. So again, what is the x variable? The x was time in days, so I'll put that on the x-axis. And the y variable was distance in miles. All right, sweet. Almost done. Part D says, use your equation to predict the distance traveled after 6 days. Compare the predicted value to what you calculated with the actual value. What do you notice? Okay, so a lot going on here. So the first step, it says, use your equation to predict the distance traveled after 6 days. So I'm going to use my equation, y equals 9.1 x plus 4.8. And we're going to use this to predict after 6 days. So I'm going to plug in a 6 for the letter x. So y equals 9.1 times 6 plus 4.8. If you did this in your calculator, you would get 54.6 plus 4.8, which gives you a value of 59.4. So what this means, guys, is according to the equation, so remember, this is the equation, this is what's predicted if he were to travel for 6 days. Now, what did he actually travel? Now, to look at what he actually traveled after 6 days, I'm going to look at the table. He actually traveled a total distance of 63 miles. So the equation is the predicted, and then I'm going to write over here like 63 is the actual. And what we really want you guys to see here is that the line is a prediction. The equation is a prediction. And it's not always going to be exactly what happens. Like, he actually traveled 63, and what was predicted was 59.4. So all we can say is he actually traveled farther than predicted. All right, that's it for the first page.